ഹായ്. അപ്പം രണ്ടാമത്തെ ലെക്ചറിലേക്ക് നമ്മൾ കടക്കാം. അപ്പം ആദ്യം നമ്മൾ ഐ തിങ്ക് യു ഗോട്ട് എൻ ഐഡിയ റിഗാർഡിങ് ദി ബേസിക്സ് ഓഫ് സർഫസ് ടെൻഷൻ ആൻഡ് ഹൗ ഡു യു ഡിഫൈൻ ഇറ്റ് എന്നോ. സോ അടുത്തത് വി ആർ ഗോയിങ് ടു എ തിയറി. Okay. So how to explain, how to account for this surface tension that is given by the molecular theory of surface tension as suggested by Laplace. Okay, so next we are going to the molecular theory. This is important as far as your examination is also concerned. So molecular theory of surface tension was given by the scientist Laplace. So I'm going to draw a surface liquid, a beaker containing water. So it is filled till this. Okay, water is filled in the beaker till as shown in that figure. Now there are molecules, water molecules all over this surface. Now I'm going to draw actually three sphere of influence. Okay, consider these to be the one molecule is inside, and let this sphere be the sphere of influence. Now another sphere of influence is like this. Okay, and one more is something like this. Okay, let me name this as, this sphere is P, this is Q, this is R. So you can see these to be the sphere of influence P. Now try to make out the differences between these three spheres of influence. As you can see, P, the sphere of influence P, as far as the P molecule is concerned, it is well inside the surface, inside the liquid. So this molecule is under tension from all other, or it is equally attracted by the all other molecules. Okay, so it doesn't have a net resultant force. It is at, say, at rest inside the liquid. Now coming back to Q, the molecule Q, you can see that this is also majority of its sphere of influence lies inside the liquid only, but a few, very few, say some 20% of it is above the liquid surface. Okay, that is above the liquid surface, so it is attracted, or it is under the there is no other molecule on top of it to interact with, but majority of the atoms it interacts are inside the liquid, so there is a net pull downward on it, okay, by the molecules of the liquid. Now the case is entirely different here. You can see this has a sphere of influence which is 50-50. That means 50% of its molecules are free to interact with liquid molecules below it, but 50% of it is above it. So again, the lower molecules try to pull it maximum to the downwards, and it doesn't have a molecule on top of it to interact. It's air or vapors. So this down molecule, the liquid molecules below that surface will try to pull it maximum downwards. So these three different scenarios, that is the molecule P, molecule Q, and molecule R, tell us that there is something different happening on the surface of the film. So it is unlike P. P in it is very well inside the liquid. It can equally interact with all other molecules. It is at rest, you can say, or it doesn't have an unbalanced force in it. But Q, you can see there are unbalanced force, but majority of the molecule is below the surface, so there is a net downward force for the molecule Q. But CR, the molecule R, as far as R is concerned, 50% of it is below and 50% above it. So there is a net downward pull. All the molecules below the molecule R try to pull it maximum to bottom. So make out understand that there is a difference in the mechanism for P, Q and R. R is under a tension because it is being pulled maximum to the bottom part. Okay, so now what we can understand is that whenever you need to move this P to this place, to the top of the liquid, I mean liquid surface, then you have to do work because it is under a tension. It possesses a potential energy. So whenever we need to move a molecule from the inside to the surface of a liquid, work has to be done, and this work gets stored as the potential energy. So there is the potential energy of the molecule on top of the surface, that is the surface part is different or more compared to the potential energy of a molecule deep inside the liquid. So this difference, this potential energy, this difference in energy, or this work done to take a molecule from the interior to the top surface gets stored in it as the potential energy. And every molecule or every system tries to in equilibrium, tries to come to equilibrium, and they have a minimum potential energy. So every molecule will try to reduce the potential energy. So how do they do it? Because the number of molecules, they can't do anything because it is fixed. It is fixed by that range only. So it can decrease its surface area to reduce the potential energy. So every molecule on the surface has basically a tendency to reduce its surface area by being under a tension. Okay, so we have said about this work done, or it got a potential energy there, right? So we are going to define what is a surface energy. So we have seen that free surface of a liquid, they have a tendency to contract and possess a minimum surface area. And if work is to be done to increase the surface area of a liquid, as we have seen, okay, otherwise it doesn't nothing happens. So work has to be done to increase the surface area of the liquid, and that work gets stored as the surface as its potential energy. So surface energy, we define it as the excess potential energy per unit area of the film. That's how we define the surface energy, excess potential energy per unit area of the film. Now let's see how we can relate, or what is the relationship between this surface energy and surface tension. For that, let's consider surface A, B, C, D. Consider this to be some A, B, C and D. So consider two parallel surfaces AD, BC. Okay, and the length AB is L. Okay, they are AD and BC are L apart. Okay, now let's assume that this one, right, this CD, let it be this way, the CD. Oh, okay, so assume this is the straight line. Okay, so this CD is movable. Let's say that this CD can be moved. Now we are dipping, this is a rectangular piece. I'm just dipping it into a soap solution. There is a film formed on top as well as on bottom. A film is formed. So as soon as a film is formed, this CD can move up, say by a distance x, that is to a new position C prime and D prime. Let that be this much, and let this distance be x. Sorry, x. Okay, let the distance it moves up be x. Now, what is the force acting on this C prime D prime? How did it move? Because it is under a force, and that force acting will be T. We have already seen that is T into L, right? Force F is equal to T into L, but here there is a top surface as well as one bottom surface. So there are two surfaces and hence we have to take it as 2TL. Okay, so 2TL will be the total force acting on the surface. Now what is the work done in that case? Work done is force into displacement. Therefore force we have got it to be 2TL and multiplied by x will give you the total work done. 2TLX will be the total work done. Let me write it properly. So W work done W is equal to 2TLX. Okay, now we have defined this surface energy to be work done per unit area. What is the area of the surface? Length into breadth, right? So length into, this is L and this is X. So area will be L into X. So area A is equal to L into X. Again, here we have to take as 2 times Lx. Why? Because there are two surfaces. ഒന്ന് മുകളിലും ഒന്ന് താഴെ. അതാണ് ഈ രണ്ട് surface എന്ന് പറയുന്നത്. Therefore, surface energy is equal to work done per area. That will be equal to what? 2 into T into Lx divided by L into X. You can say, sorry, you can see 2TLX divided by 2LX. That is the total area. So that will be equal to T. Okay. So this work done, surface tension is numerically equal to the or it can be defined as work done per unit area. Work done per W by A. Okay, that is the that's also one method of defining this surface tension. So this is the idea behind the we have discussed about molecular theory of surface tension, Laplace's molecular theory of surface tension, and how we can account for the surface phenomenon. Surface tension, as I've told you, is a surface phenomenon. It acts for all those molecules on the surface of the liquid because there are no molecules on top of it to balance the forces of the molecules below it. So this is a surface phenomenon and work is to be done to bring a molecule from interior to the top of the surface, and that work will be stored as the surface energy. And we have seen the relation between surface energy and surface tension. So surface energy W, it is the work done per unit area. Okay. So this is the about molecular theory of surface tension and the surface energy part. Next we have a derivation that will be dealing in the next video. Okay, bye for now.